Okay. Shapes in the form of equilateral triangles can be made using matchsticks of equal length. The shapes are then put together into patterns beginning. The beginning of the sequence of these patterns is shown below. Draw the fourth sequence in the pattern. Okay, so the fourth sequence is basically going to be just draw another set of matchsticks up. So basically, if I want to draw the fourth one, I'm going to use the existing one to draw the fourth one. Okay, all I'm going to do is this. Now, let me do a quick count first. 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it goes 3, 9, and then the third one. 1, 2, 3. Oh wait, 1, 2, 3. Yeah, probably do. And 11, 12, 13, 14, 15, 16, 17, 18. Okay. 3, 9, 18, alright?
Correct them.
Now, 3, 9, 18. Now, I'd have no indication that this is a 3, 9, 18. I'd have no indication that this is a quadratic sequence yet. I wouldn't have any indication whatsoever. Okay? So what I'd have to do is just concentrate on making my next one. Okay? So 3 triangles on the second pattern. On the third pattern, 1, 2, 3, 4, 5. 5 triangles on the pattern after that. So I'm going for, I think, 7 triangles now.
Yeah.
Okay, then the next one over. And then.
So I don't know what sort of way you're drawing these.
Yeah, so you made a bit of a mess with it.
There's not.
Yeah,
It should be flush.
Yeah, that works.
Sir,
We'll just add them all on.
see, we're not just adding another row at the bottom.
Yeah,
Sorry?
Like, we're not just adding another row at the bottom.
Oh, sorry, I do have to add another row at the bottom.
that's all you do.
Oh, so that's all I have to do, sorry.
Oh, you did the same thing.
Sorry,
Yeah.
I just had to add another one on top. Oh, sorry, like this.
Yeah.
Yeah. No, what? No. Jesus.
Yeah, no, yeah, you get it. You get it. That's
Ah,
right.
yeah.
That's what I did.
Okay, guys, there it is there. More or less the same thing I just did. Now, what did I say was earlier? 3, 9, 18, right? So, this was 18, so add on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Add on 12 to get us to 30. Okay? So 3, 9, 18 and 30. Everybody happy with that?
Yeah.
Okay, so not much surprises in question A. Marks on the board. Okay? Now, 3, 9, 18 and 30. Okay. So, 3, 9, 18, 30. Now, pattern 1, 2, 3, 4. Number of small triangles, okay? So, number of matchsticks we have sorted. What was the number of small triangles in the second one again?
4.
4, and the number of small triangles in the one I just drew? 16. Now, guys, you can examine this sequence here. Look, 1 squared, 2 squared, 3 squared, 4 squared. So I'm assuming the next one's going to have 25. One after that, 36. Now, write an expression in n for the number of triangles in the n pattern of the sequence. Well, I could do this 2 ways, okay? First way I could do it is I could look at I could identify that it's n squared. Would you agree with that?
Yeah.
Tn equals n squared. Now let's imagine you don't have that sort of eye. We're going to do it the long way anyway, right? So T1 is going to be 1, 4, 9, 16. Do your 2 tests. First difference, not the same. Second difference, same. Tn equals an squared plus bn plus c. Then you can say that, look, a is 1 because it's half the second difference. So we're going 1n squared. T1 is 1 and T2 is 4. So let's find out. It's going to be 1 squared plus b plus c equals 1. B plus c equals 0. Okay? Then we go for the second one, which is T2. And we go T2 equals 2 squared plus b times 2 plus c equals 4. 2b plus c equals 0. Okay? So now we have 2b plus c equals 0. Change this into minus b minus c equals 0. We're going to get b equals 0. And then we're going to get c equals 0. The only thing that has a value is a. So Tn therefore equals n squared.
Boom.
Okay, same thing. Now, doing next, guys, is we're going for the sequence for the triangles. Number of matchsticks, guys. This time we're going for number of matchsticks. Once again, what did we say again? 3, 9, 18, and 30. Once again, run off your first difference. 6, 9, 12. Run off your second difference. 3, 3. So we know it's 3. Okay? Tn equals an squared plus bn plus c. Therefore, Tn equals 3 over 2 or 1.5 n squared. Would you agree with that? Half the second difference. 3 over 2 plus bn plus c. Okay, now there are no equals there. Do T1. T1 therefore is going to be 1.5 plus b plus c equals 3. b plus c equals 1.5. T2 therefore equals 4 times 1.5, which is going to be 6 plus 2b plus c equals 9. Therefore 2b plus c is going to be 9 minus 6, which is 3. Then bring down this and multiply by minus 1. B is also going to equal 1.5. And because b equals 1.5, c has to equal 0. So our Tn formula now becomes, what does it become? 1.5 n squared plus 1.5 n. Okay, upon completion of that, what I ask you to do then is go, what is the n minus 1 pattern of the term? n minus 1. So, what you do here, to find n minus 1, anybody can tell me how to find n minus 1? If that's Tn, anybody want to tell me how to find Tn minus 1? Sub in n minus 1 for n. So Tn minus 1 is going to be 1.5 multiplied by n minus 1 squared plus 1.5 into n minus 1. We all know n minus 1 squared is n squared minus 2n plus 1. Multiply the bracket out twice. You get 1.5 n squared minus 3n, because we're multiplying it all by 1.5. And then plus 1.5. And then we're going to add it to 1.5n. Is that right? 1.5n minus 1.5 plus 1.5. And then, what'd you say?
1.5 minus 1.5.
Yeah. And then minus 1.5, yeah? Everybody happy enough with that?
1.5.
What? N, yeah, you're right. Now, the number of matchsticks in the end pattern of the sequence, one expression in M, the number of matchsticks to turn. Sorry guys, we haven't finished this one off yet. It says, find expression in N to turn the number of matchsticks needed to turn the n minus 1 pattern into the n pattern. So what I basically did there was Tn minus 1. I haven't done that yet though, have I? No, I only found out what Tn minus 1 was. So I haven't found out what Tn is yet. So I have to take this one. Oh dear, wasn't meant to do that. Sorry guys, I was meant to find out what this one, take away this one is. And what is this one, take away this one?
0.
No. It's 3n. 1.5 n squared plus 1.5 n. Take away everything in here. The 1.5 n squared minus the 1.5 n. minus minus makes it plus. There's 3n difference between the matchsticks in each one. Now, let me put that into perspective for you. Everybody in the class would agree. 3, 8, was it 3, 9, 18 and 30. Now look at this. I'm saying that the gap is going to be 3n every time. Is that true? Let's find out. When n equals 2, very important here, guys. When n equals 2, we're talking about this gap here, the gap between 2 and 1. Lads, Megan, please pay attention here. We're talking about n equals 2, it's the gap between 9 and 3. 3 times 2? 6. When we're talking about n equals 3, we're talking about the gap between 18 and 9. 3 times 3? 9. When we're talking about n equals 4, we're talking about the gap between 30 and 18. 3 times 4? It works for any gap. It's the gap between the big one minus the one before it. So whatever n is, it's that one minus the one before it. Now, the number of matchsticks in the nth part in the sequence can be represented by a function. We've already done this. This function is going to be 1.5 n squared plus 1.5 n. Find the values of a and the values of b. We already found that out, didn't we? 1.5 and b equals 1.5. Finally, leaves question E. One of the patterns has 4,134 matchsticks. How many triangles are in that pattern? Triangles are n squared, correct? Our formula for number of matchsticks is 1.5 n squared plus 1.5 n equals 4134, yeah? Bring it over to your side, then I reckon multiply everything by 2. Multiply everything by 2, 3n squared plus 3n, and what's twice that? 8,268. Does anybody have the two numbers that turns into, what page is it on again, Simon? 52?
Right, 51. See minus b on that.
Yeah, I just wanted to find the minus b on that. Minus b, guys. A equals 3, b equals 3, c equals minus 8,268. When you put into the minus b form, you get two answers. You get n equals 52, and you get n equals minus 53. It cannot be minus 53 because there's no such thing as a negative term in a sequence. Therefore, n equals 52. Now you might be asked, how many small triangles take place in there? Sorry? How many small triangles are in that pattern?
Yeah.
Okay. So, what's the answer in the back again?
52 squared, is it?
Sorry?
52 squared.
Okay, so as discussed before, the number of triangles is n squared. Square 52. 52 squared gets you 2,704.
That one.